So in this lesson, we're going to be talking about independent and dependent events. And when you see the description, you're going to see the word and, just like a compound sentence. For example, Mrs. Dowen went to the store. She bought a Diet Coke and a bottle of water. So she did both things. And when we use the word and in our probability, that's going to tell us that we need to multiply. This next slide is talking about independent and dependent events. You can go ahead and read through that. And basically what it means is that if it's an independent event, it doesn't affect one another. For example, if you toss a coin twice in a row, when you toss the coin once and then you toss it again, the second toss, it doesn't matter what you got on the first toss. A dependent event affects the other one. So for example, you're drawing a king from a deck of cards and then you draw an ace, but you didn't put the king back in the deck, so you are drawing from less cards. So we'll show you how that works. First problem, you are playing a game that involves the spinning the money wheel twice. What's the probability that you get more than 500 on your first spin and then you go bankrupt on your second spin? So let's find the more than 500. So here's a 5,000 and a 650, a 750 and a 950, a 3,000, a 900, a 700, and a 550. So it looks like there's 8 places on the wheel that have more than 500. So that'll be 8 over, there are 24 spots on the wheel. Then times, we want bankrupts. So let's take a look and see how many bankrupts there are on the wheel. Looks like there are 2 bankrupts. Now, because that wheel, once we spin it and we spin it again, it doesn't matter what we spun the first time because we're starting all over. It's independent. So we're simply going to multiply these two together, which is 16 over 24 times 24, but we can simplify first and then we don't have to worry about that. So if I simplify my fraction, 8 over 24, 8 goes in here once and 8 goes in here 3 times, and I can simplify this to be 1 over 12. So when I multiply, I get 1 over 36 as my probability of spinning more than 500 and going bankrupt. Okay, on the next problem, we're talking about marbles. So it says a jar contains red and blue marbles. You randomly choose a marble from the jar and you do not replace it. Then you randomly choose another marble. Tell whether the events are independent or dependent if the first marble you choose is red and the second marble you choose is blue. Now remember, you're not going to put it back into the bag. So this is going to be a dependent event because you did not replace the first marble. And that means that you are going to be picking from less marbles the second time. So the second selection is going to depend on what you picked the first time because it has less marbles to choose from the second time. Okay, as part of a board game, you need to spin the spinner at the right, which is divided into equal parts. Find the probability that you get a 25 on your first spin and a 50 on your second spin. So a 25, so there's 2 25s. 2 25s out of 8 slots. Find the probability that you get a 50 on your second spin. Well, there's 150 out of 8 spots. And again, because these are once I spin the spinner, I start all over. These are independent. They do not have an effect on one another. We can simplify first, and then we can multiply. So the probability is 1 out of 32. Okay, on the next problem, we have a bowl of grapes. We have 36 green grapes and 14 purple grapes. You randomly choose a grape to eat and then randomly choose another grape. Find the probability that both events A and B will occur so that the first grape is green. Well, first we have to find the total amount of grapes that are in the bowl. So we're going to add the two together. So 36 plus 14 would be 50 grapes. So the probability of you picking a green grape to start with, you'd have 36 choices out of 50. And I'm going to eat another grape. So what's the probability that I eat another green grape? Well, the thing is you ate one of them. So that means now we only have 35 choices for my green grape the second time, as well as the fact that since I ate a grape already, I'd only have 49 to choose from. So this is an example of where this is going to be dependent because I ate the first grape, which means there is less to choose from. Okay, so it would be best if we could simplify these first so that we wouldn't have to multiply such big numbers. So 2 goes in here 18 times and 2 goes in here 25 times. And then we could divide each of these by 7. And so the other thing we could do is, remember, when you're simplifying, you can also simplify directly across as long as you go one numerator and one denominator. So 5 goes in there once and 5 goes in here 5 times. So when I multiply top times top and bottom times bottom, I'm going to get 18 over 35 as my probability. Okay. Next question, tell whether the situation is independent or dependent and then answer the question. A drawer contains 12 white socks and 6 black socks. You randomly choose one sock and you do not replace it. Okay, so do not replace means that it's going to be dependent because you did not put it back in the drawer. What's the probability that both of them are white? So first of all, we have to come up with how many total socks we have in the drawer, which is going to be 12 plus 6, 18. So the first probability that both of them are white. So the first white I select, I have 12 white to choose from out of 18 socks. Now, since I didn't put it back in the drawer, now I only have 11 white socks to choose from out of 17 total socks. Again, because I did not put it back in the drawer. So I could simplify before I multiply by dividing both of those by 6. So then we can multiply straight across. 2 times 11 and 3 times 17. And that will be the probability of choosing a white sock and another white sock. Next, suppose you flip a coin twice. What's the probability that you get tails on the first flip and then tails on the second? Well, remember that flipping a coin is independent because the second flip doesn't matter what you got on the first. It's starting all over. So remember, the probability of getting tails is 1/2, and then if I'm going to do that again, it's again 1/2. So 1/2 times 1/2 would be 1/4, because remember, we're starting over each time. Okay, next is going to be some playing cards. So You randomly select 2 cards from a standard deck of 52 cards. What's the probability the first card is not a heart and the second card is a heart if you replace the first card? So there are 13 hearts in a deck. So if I don't want a heart, I'm going to subtract 13 from 52, which means that there would be 39 other cards, which would be the spades, the diamonds, and the clubs out of 52. And it says you replace it. So when I replace it, that means that I'm going to start all over and have all the cards back in the deck. And then it says the second one is a heart. So that's going to be 13. So before I multiply, again, it's much easier if I reduce or simplify. So when I multiply straight across, I get 3 out of 16, and that's for letter A. Letter B is the exact same question, except this time I'm not going to put the card back into the deck. So I do have 39 cards that are not hearts out of 52, and I do have 13 hearts, but this time I'm only picking out of 51 cards. So in this case, when I multiply straight across, I get 39 out of 204. But if you didn't see, we can simplify that. 3 will go into both of these, so that's going to be 13 over 68, and that's without replacing the card. Next, you randomly select 2 cards from a standard deck of 52 cards. What's the probability the first card is a heart and the second one is a club if you replace? So if I replace them, it's an independent event. It didn't matter what I got the first time. So the first one's a heart. That's going to be 13 out of 52. And the second one is going to be a club, 13 out of 52. Again, before I multiply, I may want to reduce to make things a little bit easier. Then I don't really even need the calculator. And my probability is 1 out of 16. In the second example, letter B, it says do not replace. So this one's dependent because I'm going to be drawing from less cards. Still, the first card is a heart, which is 13 out of 52. The second card is a club, but I'm only picking out of 51 cards. So when I do not replace the card, I have less choices. Let's reduce, and then we're going to multiply straight across, and we have 13 out of 204. So this is independent and dependent event.